Hi there, and thanks for joining me for a Calculus 1 short lesson here on an introduction to some of our limit laws. Now, each text will probably have all of the limit laws written out in a very readable format, so you might want to take a look at that. We're just going to go ahead and start by applying what might be some of the more intuitive limit laws. So if I just asked you to find the limits, and hopefully after looking through the previous section that you did, you'll hopefully understand that the first thing you should always try to do with limits is just substitute in that value that you're given to see if direct substitution will work. So here, if I substitute in the 4 for x, I have the cube root of 4 plus 23. And I can evaluate this. 4 plus 23 is 27, so I have the cube root of 27, which is 3. So in this case, and I could look at the graph of that cube root function as well, but I should be able to see that I will have a point 4, 3 on that cube root function's graph. I can show you that now. All right, so here's this cube root function. I just went to y equals, typed in the cube root of x plus 23, just as it appears here after my limit. Graph it in that standard negative 10, 10, negative 10, 10 window. And here's what I see. And I can actually see that if I go second calculate a value and I type in x equals 4, my function is continuous here, and we'll talk about continuity as the sections progress, but my function is continuous here. My two-sided limits are the same, and my function has an actual value at x equals 4, and that value is 3, so that's also its limit. All right, so looking at the next one, we're doing the same thing, we're just doing it with a trig function. So if I substitute in 5 pi over 6 for x, I have the sign of 5 pi over 6 that I should be calculating or evaluating. Now we should not be using our calculator to get this value. We should know from our trig course prior or pre-calc course prior what this value is. So let me just draw an idea here of where this is. So 0 pi and come around to 2 pi in terms of radians. And we should know that 5 pi over 6 is 1 pi over 6 short of pi, because in terms of 6, pi would be 6 pi over 6. So I'm 1 pi over 6, or 30 degrees shy of that. And if I'm on a unit circle where my radius or hypotenuse of that right triangle is 1, then opposite my 30 degrees will always be a 1/2, and opposite that 60 degrees will always be the square root of 3 over 2 side. And then I just make those sides positive or negative based on the quadrant that I'm in. Well, since I'm moving left, the x value will be negative. Moving up, the y value will be positive. And so now when I'm evaluating the sine of that angle, I can either look at it as opposite over hypotenuse, or since my hypotenuse has a value of 1, we can just look at that opposite value or y value, which is 1/2. And since it equals, then that's my limit. I was able to evaluate it. So I think this is the last one that we'll take a look at for this pre-lesson video here. And what this idea is now we're telling you that the limit of some function as x approaches some c value, we're telling you that that limit is 4. Okay, we're not going to give you the actual function. Rather, we're going to tell you the limit of that function as x approaches c, which is the same thing that you'll see right here. Limit as x approaches c of the function, but in this case, you're cubing the function. So guess what you would do? If you guessed you would cube the limit, then you would be right, because you are cubing that limit, right? Or that y value, or that output. So this should just be 64. So you'll see limit laws written out in such a way, for example, I could say the cube of the function. So if I take the limit of the cube of the function, it's the same thing as taking the limit of the function and cubing it. And then the same thing would occur for question B. If you have the limit as x approaches c, same x value, right, of the square root of your function, that's going to be the same thing as this limit and now the square root. So this should just be 2. So I hope you found this a little bit intuitive, that if you can substitute it in, please do so. Or if you think that something might be true, it probably is. Thanks for watching. More to follow.